From Chicago, welcome to 3Degrees Discussions. I'm your host, Mike Vasquez. This is a podcast devoted to the stories behind the innovators, entrepreneurs, and leaders in the 3D printing industry.
There's probably two or three reasons why people call me. One of them would probably be because the building code official told them they have to. Another one may be that they realize the building code official is going to ask some questions that they can't answer.
That was Jason Reason. Jason is a widely recognized expert in safety and health with a special emphasis on combustible dust and industrial hygiene. Jason has performed hundreds of dust hazard analysis for all types of combustible dust in a myriad of industries, including additive manufacturing. He serves on a total of 6 technical committees and actively coordinates efforts to reshape combustible dust, safety, and health standards. While serving on these committees, Jason has written several new requirements to address serious combustible dust hazards, including developing new requirements for DHAs and NFPA 652, and additive manufacturing in NFPA 484, as well as the International Fire Code. Before we get started, head over to www.3degreescompany.com and subscribe to the podcast. Remember, you can listen to the show anywhere you download your podcasts, including Spotify, Apple, Amazon, or Stitcher. Jason, thank you so much for joining the show today. We're excited for the conversation. It'll be kind of really focused on kind of safety around the additive space. But kind of before we get into kind of those details, I always like to play some context with people and hear kind of a little bit more about kind of their story growing up, kind of where they're from, kind of what kind of got them started on the path where they are now. So welcome to the show, and maybe let's start there.
Yeah. No, happy to be here. Where I get started in additive manufacturing, that's always a question. But I started out my career after going to school at Purdue for industrial hygiene, working for Indiana OSHA as a compliance officer. So did that for about 12, 13 years, and then broke off and actually started doing combustible dust consulting, which is something I got into while I was actually an OSHA compliance officer. The last 5 years, I pretty much did most of all of the combustible dust compliance inspections related to, including fatalities, related to combustible dust explosions, to the point where I actually started to train federal OSHA people and other state OSHA people, which is something I continue to do to this day, along with fire marshals, insurance carriers, and building code officials. But so I did that for a little bit, as far as, didn't start my own consulting company, but basically started one from scratch for another company. And about 6 years ago, is it been that long? Yeah, 6 or 7 years ago, had somebody come up to me at a conference, can't say who it was, but asking about 3D printing. Do I do this stuff? And at that point, I mean, I've heard of 3D printers, but I never actually looked at one. I didn't even know they use combustible dust, but they do. And that started me doing additive manufacturing, to the point where now, in those, about the 7 years I've been doing AM, I've done well in excess of 250 projects related to 3D printing, working with all of the, when I say working, some good, some bad, with all the equipment manufacturers in terms of 3D printer people, the other ancillary equipment, powder producers, pretty much everything out there. And even to the point where, I sit on 5 NFPA committees to help write these standards, but which I'm sure we'll talk about what's happening in the standard development world. But back in 2019, NFPA 484, which is the combustible metal standard, became the first standard in the U.S. to actually cover additive manufacturing, or try to. And I wrote about 25% of that chapter in that standard. The new one just came out, the 2022 edition last year for 484. I probably wrote close to 75% of that chapter now, with all the stuff I was seeing out there and all the deficiencies. So it's kind of come full circle. But yeah, I do a lot of work with 3D printing, whether it be just doing the additive manufacturing dust hazard analysis, or the DHAs, even doing the things where people contact me to help get their building approved by the building code official and the fire marshals, because that's a big issue for a lot of these people. So, but that's just a little bit about me and how I got into additive manufacturing. So I don't see me leaving AM anytime soon. So, but
yeah, I would say you probably have seen the inside of more AM facilities than pretty much anyone out there.
pretty much. And, you know, I've examined more printing equipment than I probably ever want to see in my life. Because for to do one of these DHAs, I have to read all these manuals. People don't believe me when I actually read these things. So on a typical DHA, I read about 1,000 to 3,000 pages of material, just to make sure I understand everything. And you know, but I know, like I said, some 3D printer people love me, some of them hate me. So the term "most hated person in AM's" been thrown around there. Yeah. So, but no, I definitely get to see a lot. So
let's, I mean, for some of the folks kind of more kind of new to some of the materials space, like, I mean, let's start kind of basic. So, I mean, you threw out the word combustible dust. And so maybe we just kind of start there, because I think a lot of the work you do is mostly in the metal space, but there are polymer powders and things out there. But kind of when you think of kind of some of these early hazards or kind of big definitions, kind of what do you mean by combustible dust?
So combustible dust is basically when you get a dust or a powder, you get it small enough in terms of particle size where you can actually make it explode. And there's a lot of things you need to do that. I mean, you need to get the cloud in the right concentration. You need to hit it with the right ignition source. And if you do that, you're going to have a deflagration, which is like a combination of you'll first have a pressure wave come out and then a fireball come behind it. Or you can actually get an explosion where you actually burst the container open, or potentially a flash fire, which is that whoosh fireball you ever hear everybody talk about. That's 3 seconds and it just whooshes itself out. But that term combustible dust has been around for a while. Most people are aware of it, especially people like that work in food and wood. Some people aren't. I mean, I still shock some people, and I don't know how, when I tell them that flour is combustible. The stuff you buy at the store, you can actually take and blow it up at home. And please don't do that, but you can. Sugar, you could do that with sugar, grain, dog food. All this dust is explosive.
Yeah, did they have some like concert issues, right? Like in Asia a few years ago, right?
Yeah.
With some like those big dust festivals. Okay.
It was colored cornstarch is what caused it. Yeah. So, and then wood, I mean, the wood industry is very familiar with this. It doesn't matter what species. You get it fine enough, even sawdust, you will get fires and explosions from it. The 3D printing people, it's a relatively new type of thing, because I don't think anybody really thought of it. But you can primarily break the combustible dust for AM down to 2 different categories. You have your metals and you have your polymer / plastics. Now your spooled plastic stuff, that's not a combustible dust concern unless you're going to shred it or regrind it. And so far, I haven't seen anybody do that. I'm positive eventually they will, just like they do for plastic bottles, like Gatorade bottles. The rejects, they regrind those, and that's where they have their dust problem. So like the polymers, for example, your stuff like PA12, PA11, PA2200, all these different formulations for those polymers, those have all been shown and tested to be explosive. When you get into the metal side, there's 3 of the most common that you get into. Number 1 is titanium. Whether it be Ti 64, I have a lot of people using now Ti 642. You know, I even have this new one, Ti FE, that one of my clients is using. Titanium is really titanium. They don't really change that much, just you put more of it in there. But all of those have been proven explosive. Your aluminums, so you're like your ALS I-10s, your F357s, all of those have been shown to be explosive. And then you get into your iron powders. So like I know Praxair makes a lot of this iron stuff. Not to pick on them, but yeah, I mean, basically, so those 3 now. I do have a couple of exotic clients out there that are using zirconium, which is also explosive, and I always say it wrong, but niobium. I always say niobium because I think I'm in the Matrix or something. But yeah, basically, those 2 are also explosive. And then I have a couple of clients that have told me they were going to be brave, but they didn't go brave, to use tantalum or magnesium. Now, if you're going to 3D print with those are definitely explosive, especially magnesium. But most of the metals out there are going to be explosive for the most part. The stuff that won't would be like your stainless steels. Those aren't explosive. So, there's a few other ones out there, but stainless is the one I'm running into a lot. That you could test that, and we haven't seen that come back explosive except in very rare cases.
Even at small particle size?
Even at small particle size. It's something to do with the chromium in stainless that's preventing it from being explosive. Because the same thing happens with cobalt chrome. It's not explosive either.
Interesting. So it's not just a definition of, hey, if it's under 500 microns or something like that, kind of consider it combustible. If you do the explosion, or like there's ASTM tests, right? Like that you can do.
Yeah, there's an ASTM test you could do. It's ASTM 1226, but for the most part, these powders have been tested to death. And one of the nice things for AM for the people is that you don't really need to retest them because you're not really doing anything with them. You're taking a 40 micron powder and put it into a powder bed printer. So you can use testing data from another facility because it's representative, or you can use it from the powder manufacturer if they did it. Sometimes they do their own testing. But yeah, I mean, typically NFPA throws a size out there of 500 microns, like you mentioned, which is about the consistency of sand, give or take. The smaller the particle size, the more explosive it is. So most of the metal powders out there are 75 microns or less, which is about powdered sugar consistency. Those start to get pretty explosive, but even with metals, though, the KST, which is how explosive it is, that value, it doesn't get that high. In fact, a lot of the stuff I deal with on the titanium alloys and aluminum alloys, flour and wood are more explosive than those. That's not to say that the hazard's not there. Don't get me wrong, but there's a lot of reasons for that. The primary one is oxidation. Those metals oxidize pretty fast, and the faster they oxidize, the less explosive they are. Like you can get iron dust, true iron dust, to explode. You make it into rust. I don't care what you do to it; it's not going to explode. So yeah. So there is a difference there. So metals are unique in that perspective, but a lot of times, and people don't believe this, that the polymers in plastic are actually more explosive than the metals. So sometimes their KST values are double what the metals are.
Interesting. And so as you start with, like, I mean, we can go through kind of maybe the first side of things on the user side. I mean, when people buy 3D printers, I mean, or even any industrial kind of manufacturing equipment, right? There's some baseline assumption that like, hey, like there are going to be risks, like, and there are going to be kind of hazards associated with that. I find that for 3D printing, because there's so many different steps and there's different materials involved, and people are a lot of times new to it, and like kind of scale is different. It may start in an R&D lab and prototyping, then go into production. But like, what are some of the kind of why do people call you? Like, I guess when are the situations that you get called in terms of helping to navigate some of the safety stuff, the dust hazard analysis, kind of when do you get involved?
So there's probably 2 or 3 reasons why people call me. One of them would probably be because the building code official told them they have to. Another one may be that they realize the building code official is going to ask some questions that they can't answer. So, and both of them translate back to the same point of what I do, especially on the front end of this. But so the way the codes are written, especially like the International Building Code and the International Fire Code, which most states have adopted, which most people don't realize have combustible dust requirements in them. So it's in state law in all 50 states here in the U.S. So you're going to deal with it one way or another. But people always ask me, why do we get picked on in AM by these building code officials and fire marshals? And there's one reason why you get picked on, if you're ever wondering. It's because you're going to store 100,000 pounds of powder on site, or some astronomical number that is going to scare the holy hell out of these people. because I hate to say this, but most of these building code officials and fire marshals and insurance carriers don't understand combustible dust. They just don't have the knowledge. It's not their fault. They don't understand it. I train a lot of them. Trust me. I try to get them in there because it makes it better for everyone if they understand these hazards. But when you tell somebody that, because I've been to feed mills, which believe me, feed mills blow up so much more than 3D printing. It's not even close, and they don't treat them as hard as AM because again, they don't understand the flour, they don't understand the grain, they don't understand that stuff. They think that's less of a hazard. But when you tell somebody, yeah, we're going to store 200,000 pounds of aluminum on site, yeah, they're going to start asking some questions. Especially when you tell them you're going to store it in a very, very, very fine powder. So because of that, you get into all this stuff on the front end that I learned the hard way several years ago, and I actually write stuff for the International Fire Code now for additive manufacturing. But you get into stuff about high hazard occupancy, specifically group H2, H is in Henry. And the best thing I can tell your listeners is that if you submit your plan, whether it be to build a new facility or retrofit an existing one, this is going to come up, whether you like it or not, because the building code official is going to basically try to throw you an H2. You do not want to be an H2. So, first of all, you don't belong there. I've never seen an AM facility that actually was high hazard. These are places that have a deflagration hazard from combustible dust. And because of that, there's a bunch of controls that kick in for the building design, including fire-rated walls, building damage limiting construction. So you have to actually put explosion vents on your walls so your building won't fall down. You got to have special sprinklers. You got to have control areas. You got to have all of this stuff I could go into that's going to cost you a minimum of $250,000 more on top of whatever you just paid for the millions of dollars for the equipment. Plus, they're going to make you put classified electrical equipment in, which you probably don't need. So people contact me because I'm one of these independent experts, and anybody who really truly knows you or knows me, I should say, I will tell you what I think one way or another, whether you want to hear it or not. But truly, I'm independent in all this. So if you truly need something like that, I will tell you and tell you why you need it. But people contact me to just basically make sure that they don't get put into that H2 classification if it's not necessary. And so far, knock on wood, on all the projects I've done, I've never seen one that was necessary. And I was able to convince, out of all of those hundreds of projects, I've only had one time in the state of Michigan, for whatever reason, that would not listen to me no matter what I said, that forced them to be at H2. But other than that, I mean, even here recently, I had the last 7 projects, most of them are in Ohio for some reason, all of them have come back as not H2. So, which means they could take that money and put it where it belongs, put it towards the other equipment or put it towards other controls to prevent this. So that's generally why I get called, is because, either the building code official tells them to call someone like me, or basically they see what they're recommending, they realize that they need help, and so they call me.
So when you think about the process of AM and kind of this discussion of explaining to a fire marshal why you may not, or the building inspector, whoever may be, why it may not have to be that level of safety. I mean, kind of walking through the AM process, right? You may have 1,000 pounds of aluminum, but they're all stored in kind of sealed containers. It may be in a cabinet. Then the actual time that you have open powder is fairly small, like in terms of time, in terms of the overall manufacturing process. Does that play into it, right? And then you have an inerted machine, most, like if you're talking kind of DMLS type systems, like are those some of the considerations that you have to communicate, or like what's kind of what gets them off the cliff in terms of that conversation?
Yeah, and we'll come back. I don't know if people can see me do the air quotes on the nerded. We'll come back to that.
Sure.
Yeah, because that's definitely an issue. But what gets them off the cliff? It's a good question. It's different for every type of official I deal with. I think one thing that helps me is that I was in their shoes, in terms of an OSHA person. I know what they went through. I know what they go through. They're worried about liability, and I get it. So they want somebody to just kind of sign off on this who knows what they're doing and someone they can trust. So I try to build that trust with them, to let them know that I have everybody's best interest in heart here, to do the right thing, you know. But I think what helps them a lot is just trying to explain to them, to your point, Mike, that the hazards, there are hazards in 3D printing. Believe me, there are, especially like spontaneous combustion with condensate. That's probably one of the big ones, on the metal side. But trying to explain to them that look at all the controls these people put in place. They've got electrostatic bonding and grounding to get rid of electrostatic charges. To your point, they've got quote unquote inerted equipment, which hopefully is inerted correctly half the time. So they've got, they try to limit powder dispersion when they do powder transfer into the printer and part extractions out of the printer. You try to throw all that at them to say, you can't ever say that the risk is zero. If anybody who says that, it's complete BS. No, but you try to say the risk is very, 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 very minimal. It's down to the lowest point it can get of something happening. And, just look at everything that we're doing here. And generally that helps them. And a lot of what I do on the front end with them, especially, and sometimes with the clients themselves, is a lot of education. So these dust hazard analysis are very, in terms of AM, are probably the most complex you're going to get. Like right now, I'm working on a DHA for an ethanol plant, and additive manufacturing is actually more complex than an ethanol plant, believe it or not. So that ethanol plant is like a vacation for me in a little bit of a respect. But there's a lot of reasons for that. But I mean, what I try to do is just do a lot of educating. And a good example I had is a building code official here recently told me, so you have a 5 kilo container of titanium or Ti-64. They said, well, if you drop that container, it's going to cause an explosion. I go, no, it won't. First off, it's plastic, so it won't break. I go, but even if you drop the container and all the contents released, which I don't know how that would happen, but if they did, if all the contents released into a dust cloud into the room, it would take 3 containers of all the contents releasing, and then you'd have to hit it with an ignition source to actually cause an explosion. And I go, with that much dust in the air, you won't be able to see 5 feet. By the way, you won't be able to breathe. You're well over any occupational exposure limit. So I go, you have bigger issues at that point than trying to have an explosion. You're going to kill someone because they're going to inhale too much dust. So he goes, really, you need that much dust? I go, yeah. And so I sat down and explained it to him, and he finally understood. He goes, oh, well, this really isn't that bad based on everything they're doing. I go, well, I'm trying to tell you. So, yeah.
I imagine too, like I've seen my fair share of facilities around, and I mean, or places that have metal 3D printers. I mean, we'll stick with the metal theme for now because that seems to be kind of where a lot of this comes into play. But they're in a lot of different areas, right? Like they could be in a university setting that have like just a different building structure and different controls. If you're in a big aerospace center, like they have safety controls, they have procedures already in place that are more robust. A medical facility could be completely different. And like, I imagine that adds this complexity where it's not just like a big car manufacturer or plane manufacturer that already has some sophistication in operating procedures and protocols and a safety manager, right? Like in some cases it's you have kind of like the guy who like boss said, hey, we're buying this printer and like go set it up and run it for me, right?
Yeah, I mean, the top 3 industries I deal with in order would be aerospace would be number 1, which that's a broad classification, but aerospace, and then probably medical, orthopedics, whatever you want to call it, hospitals. I've been at hospitals where they apparently want to 3D print in basements now. So yeah, more power to them. But and then the orthopedics, I call them fake joint people. They make fake something. So they 3D print everything now. And then probably automotive would probably be third. But I know one that's coming up that I'm doing a lot more of is kind of what I call the intermediary people. The people who kind of print for other people, if you know what I'm talking about, where the people can't afford the 3D printers, so they
like
hire
a service bureau.
Yeah, so they kind of print for them. but they're having to buy more printers, and when they do that, guess who starts calling? The fire marshal or the building code official. In fact, I had somebody call me here, within the last couple of months to say that the building code official said unless they got me to help them, they basically wouldn't approve their building permit and they'd shut them down. I'm like, ooh, damn. All right. So, sure.
Add a few zeros to your fee and then you'll be right there, right?
Yeah, it was more just where can I fit you in at? So yeah, that's the problem sometimes. But part of the problem on the combustible dust side, I mean, you have to be qualified to do a dust hazard analysis, which there's not a lot of people that are qualified to do that in terms of the outside people, like the consultants and the engineering firm. Maybe in the United States, you've got 100, maybe 150 that could do a DHA. So like that stuff for like flour, wood, metal facilities, stuff like that. You get into additive manufacturing, you're down to like 5. So, and I know who the other 4 are. So there's not that many. And another thing that's happening that I'm seeing sometimes, I see 2 things. When you get an unqualified person to do a DHA on 3D printing, I've seen these 2 things happen. One, that person will cause an incident because they either missed something they should have caught, or in a couple cases I think of in my head, they told them to do something that was 180 degrees opposite of what they should have done, and it actually caused a flash fire and burn someone. So because they didn't understand the hazard. The second thing that's more likely to happen is you're going to waste hundreds of thousands of dollars on controls that you don't need. The good news is you're going to be safe. That's the good news. Bad news is I had one client that I had to redo their DHA, and I estimated they probably overspent $1.5 million on stuff they never needed. And part of the problem with that is that even if you do that and you're safe, well, now you got to maintain it. You can't just get rid of it. You got to maintain it. So that costs money now. So one of the things I try to focus on whenever I do a project on AM or even the non-AM side is obviously what's the safest way to do this stuff, but what's the safest and most cost-effective way to do this stuff? Because there's always those 2 things will play together with obviously safety always trumping everything. But yeah, you definitely got to be cognizant of that kind of stuff.
And how does the OEMs come into play? I mean, right? Like you're
just trying to get me in trouble now.
Yeah. Well, no, just generally. I mean, like it's one of these things where I'm not saying it's like you buy a kind of run-of-the-mill metal printer, right? Like, and you put it in different buildings. Like there's not very many variables that are going to change between those, right? Like that it feels like there should be like, and this probably can dovetail into kind of the safety stuff, right? Like that it seems a lot of people have to start from scratch almost in terms of like just understanding the hazards, like even thinking about, hey, like you might want ESD floors in here and do that before you put the printer in. Right. Exactly. So like, and like the timing of all this. So like there seems to be, I mean, you do a lot of work at AMUG and kind of educating people around this. And I think part of this podcast is like just saying like, hey, like here are some other things that you want to think about as you get down that path in terms of buying machines or expanding buildings or getting more material or changing materials that have an impact on the bottom line, right? And how much you spend, and someone else, the fire marshal, saying like, hey, you can't do this anymore unless you call Jason. So like that, there seems to be like, there may be this stereotype still that like, hey, it's plug and play, or like you get in the machine and you're good to go, right? Like there's a lot of other factors that come into play, right? And
I wish it was that way. I honestly do. It'd make my job so much easier and make everybody's life so much easier. The problem is it's not. So whether you're looking on the metal or plastic side now, it doesn't really matter in terms of, I'm just going to deal with the printer manufacturers at this point. I've never seen a compliant printer. They don't exist.
What do you mean compliant? So, compliant for what?
Compliant with all the NFPA standards that are out there for combustible dust and other stuff. Or in this case, OSHA. OSHA does have some stuff, which is federal law now. Or even to this point, to the International Fire and Building Code, even though a lot of times they're not compliant with those either. So some are better than others. I don't want to give names out, because it doesn't really matter at this point. People know which ones I don't like. But where they get involved is they need to be involved in any DHA you do, because obviously, like I said, I look at the manuals for these printers because I need to understand. I honestly don't really care how they print. I'm more concerned about the safety aspects. But I typically, what I do is I send them a bunch of questions to kind of get some information. And I will tell you, I never thought I'd get so much pushback from people, but it is like pulling teeth sometimes with these people, especially not to pick on anyone, especially the Europeans. Because I think what happens is they follow ATEX standards. For those that know what that is, those are kind of like the European combustible dust standards. We follow NFPA and OSHA over here, which are our standards. And I have to tell them that ATEX in the United States is no better than a Post-it note. I hate to say that, but it's not. Basically, those standards are not applicable here in the United States. OSHA doesn't recognize them. And so you have to follow NFPA. And, especially it seems like the German-made printers are really problem because they all meet ATEX. ATEX doesn't meet NFPA in some cases. And so you run into problems with that. And the questions I ask, at least in my opinion, I don't think they're that bad. Some of them, again, they make it act like I'm trying to get their proprietary information, like I really want it. But questions I'm asking, like, what did you set your oxygen sensors to? What did you set your temperature sensors to? Where are they located? Do you have exposed bearings inside that process chamber? How do you unload this part? Why did you put your sensor here? What's your gas flow rate coming in? Sometimes that's in the manual. The better ones that are out there, again, I'm not saying one way or another who's better, who's good, but the better ones do put that stuff in their manual. But when I have somebody try to tell me that an oxygen set point is proprietary information, I will call BS on that every time. And it's gotten to the point where I've had legal people threaten me on DHAs. That's how, and I don't know why. I mean, I think they're scared sometimes, and I always try to work with them and tell them, look, I'm here to help you. I'll go over any deficiencies. I want these things fixed. But I think one of the things that scares people, especially on the 3D printing side, the people who make these printers, is not so much what I'm finding, the fact that everyone that they've sold prior to this, they know they're now going to have to deal with.
Right.
Yeah, I think that's what scares me. Because, okay, yeah, we can fix it going forward. What about the 1,000 we sold before this? Because one of the things about NFPA that people need to realize is there is no grandfathering in NFPA. All these standards are retroactive, which means it doesn't matter if you bought that printer 5 years ago, it has to meet today's standards. And then you get into the problem that I have some clients get that, well, what do we do now? We can't retrofit these printers because then we void the warranty. And now you get into this whole thing. But so, yeah, the OEMs are important. And like I said, there's even some here in the United States that are very difficult to deal with. They just don't like to give information out to the point where that's actually in the NFPA standard now, where it talks about you have to give us that information for DHAs. But that's how much of a problem not just me is experiencing doing these DHAs. So there's a lot of quote unquote secrecy. That's the best way I can put it. I'm trying to give this safety information out. And then even when they do, sometimes the stuff that comes out is a little scary. I mean, I had one, again, I won't mention names, who was on a phone call with a client. And I couldn't believe they said this because the client was on the phone. Because I was asking all these questions about the inert gas system. And they finally said, we don't put the inert gas system in there for safety. We put it in there for quality. And I couldn't believe they said it. And the guy goes, what do you think of that? I go, you need to do a better job of hiding it. Yeah. So,
wow.
Because it was pretty obvious they didn't inert it right. Because there's an entire standard dedicated to that. NFPA 69, it has an entire chapter dedicated to how to inert something correctly. And you could go down the little checklist. You made one, they didn't do that, they didn't do that, they didn't do that. So yeah, so I wish the OEMs were more involved. It'd make everybody's life a lot easier, but I mean, I've had clients that have got so frustrated, they told them, either you answer the question and help us on the DHA, or we'll box this up and send them right back. And I actually had a client do that. Box up their printers and send them right back, and they went with someone else.
Yeah, it's interesting. I mean, I see it a little bit on the material side. That's where a lot of my work is, kind of material development and quality and things like that. But you get even things like a data sheet, like a safety data sheet between, like, in theory, the same materials from like multiple different vendors. Like, you might as well just be making it up, because it's so different in some cases, or the testing is different. It's European standards, and so like it's hard to navigate all that, especially if from the user's perspective, right? You're not usually buying, like, you may not be buying multiple vendors or like going into detail and finding out all this information up front, right? Like you're not scouring the earth and being able to see all the different user manuals up front, right? So you kind of discover it as you go, and some of the stuff that you may not realize at the beginning when you buy it.
And it's kind of funny you mentioned the safety data sheets, because I don't think a lot of people treat those as Bible. And my best advice is, a lot of times it's not worth the paper they're written on, because half the time they guess on that stuff. I can't tell you how many times I've seen the words flammable solid and water reactive on SDSs, and it's not true. I have testing data to prove that Ti 64 is not water reactive. It's not a flammable solid. And I've tried to explain to the powder people, because it's another problem on that side, that by doing that, I know why you did it. You want to be safe. I don't fault you for that. Some of it you want to CYA, but by doing that, by putting those stuff on there, you now gave ammunition to the building code official and the fire marshal, because that's what they're going to look at, the sticky data sheet, that now I have to explain why you're not and test it. Because if I let that go, well, now this whole H2 thing kicks in again, because what a lot of people don't realize is there is no storage limit for combustible dust. OSHA doesn't have one. NFPA doesn't have one. The building codes don't have one. So you can store as much dust as you want. But if you let them call it a flammable solid, or you let them call it water reactive, you do have limits on how much you can store. Like 50 pounds. It's not a lot of dust. You won't be able to print with that.
Can't even fill a machine.
But I deal with that almost on every DHA, where I have to deal with that stupid safety data sheet that from people where I flat out call them and say, did you test it? No, we look at somebody else and we put it on there. And again, the building code official doesn't care. They think it's Bible. So now I got to deal with it. And so, yeah, it's just the one thing that frustrates me about AM, which the people are doing some amazing things, like you and everybody else. You guys are much smarter than me. I see all this stuff that's being done out there. It just amazes me. But from a safety perspective, it's like the wild, wild west. And the standards can't keep up with you guys. Even what's in 484 right now, probably some of it will be obsolete by the next edition comes out in 3 years. Good example of binder jetting. If some of the people do in binder jetting what they told me they want to do, I'm scared that these things are going to start blowing up. So just because of mixing a flammable liquid with a combustible dust is something you don't want to do. But some people want to do that as a binder now, and it just makes me shake my head sometimes. But yeah, I don't know. I'd like to say that we're getting better. I am seeing some movement among some of the big 3D printing people, that they're realizing they have to fix some stuff. In fact, I have a couple that are actually working with me at this point, where we're fixing it together, so they can meet the standards. And because at the end, that's what everybody wants. They want a safe printer that gets good quality parts and does what it needs to do. So
sure. And if you're an OEM, right, like you don't want every single customer that you sell a machine to spend an additional 6 to 8 months going through the communication process with the fire marshal, right? Like that may happen inevitably, but like it seems protracted, right?
Well, and that's the thing. The OEMs don't deal with the fire marshals and building code people. Mm-hmm. They don't deal with them. They sell a printer. So it's for people like me and the architects and the engineers to deal with the authorities having jurisdiction, what NFPA calls them, the HJs. And so, yeah, the OEMs don't even get involved most of the time. And again, when you do get them involved, they try to use these legal excuses, which I just wish they would just admit what some of the problems were with these printers so we could fix them. It's not that big of a deal. But again, it's just like pulling teeth sometimes. I mean, I can't tell you how many, like, the reason I did the air quotes on a nerdy, one of the biggest problems I see on printers is people think they're nerded when they're not. Because where they fail is in two very important failures. The most common failure is you don't maintain the oxygen or sensors. Because I have OEMs tell me that those are lifetime sensors. No, they're not. You're going to need to change them out every year to 18 months. And prior to that, you're going to have to calibrate them, which most of the big OEMs don't do as part of their biannual maintenance programs they offer. They look at them, but they don't calibrate them. And I've actually had clients that if saw their oxygen spike and then go back down, and the print and the job never stopped, the build never stopped because the sensor was broken. Yeah, and you could actually see the readout; it never stopped. It just went like this, and it's because it's not calibrated. And I don't know if it was truly above there because no one calibrated it. But that's the number one reason. The number two reason that the inerting systems just aren't there is they set the set point too high. And I'm seeing a lot of that on aluminum, especially, where they'll set it at like, this is really prevalent on the powder conveying systems. The little things with the vacuums where you take it into a vacuum conveyor to a sieve. You know, I just call those powder conveying systems just because there's only a few people that make them. But if I said names, people would know who I'm talking about. But those right there, those ones that are inerted, half the time they're not continuously inerted. They're intermittently inerted. The gas isn't on all the time. And even when it's on, they set their sensor at like 7, 8, 9, 10% oxygen. And people think, well, that's low enough. No, it has to be set at 3% or lower. So you've now given a range of 4% where you could still have a fire or explosion. So by NFPA's definition, you're not inerted. So, and it's as simple as reprogramming the sensor is all it really is. It's not a hard fix. But half the time, again, the OEMs confront people on that when you try to tell, because they have to reprogram, because they're password protected most of the time for obvious reasons. But I can't tell you how many times OEMs have fought on that they don't want to change the set point. And half the time it takes the client to shut down the printer and say, we're not operating until you come out here and change the set point.
Yeah. And so kind of maybe taking a broader look, like, can you share a little bit about kind of your work with NFPA and, I mean, what is NFPA and kind of what sorts of standards are they writing? Kind of how do you learn more about them? And kind of if you're someone kind of starting a facility or kind of like starting down this path, kind of maybe some reading literature to do or reading homework.
Yeah, sure. So first of all, OSHA is the one that most people know, the Occupational Safety and Health Administration. They're the ones where you have to follow those standards. You don't have a choice. They're federal or they're state adopted standards. If you, like in California, has their own little standards. But then a lot of those OSHA standards, a lot of people don't know, are based off NFPA standards. So NFPA, or the National Fire Protection Association. So what they are is they're kind of an independent standard writing system. And so they establish committees. So like for the dust committees, there'll be people like myself who are quote unquote special experts, so really are consultants. There'll be equipment manufacturers. There'll be users of the standards, so like facilities. And there's rules so no one group can have, basically have more than like 33% of the committee. So you can't make up a voting block to pass whatever you want. So there are rules there, but there's lots of standards out there for combustible dust for NFPA. Like on a standard AM DHA, you're going to go through at least 30 to 35 different standards. Most of those will be NFPA, like NFPA 484 for metals, NFPA 654 for plastic, 652, I go on and on, 69. But the thing with NFPA standards, a lot of people don't realize is these are updated typically every 3 to 4 years. so they stay as much as current as they can. And what a lot of people don't realize is anyone from the general public can comment on a standard. You can go on NFPA's website, go to that specific standard page, submit a public input is what it's called, and the committee has to consider it. Either they reject it as a committee, or they accept it, or they modify it, whatever. But we have to deal with it as a committee. We can't just say, we're not going to deal with that. Yeah. So anyone from the public can comment on these things. And so if you don't like something, like in chapter 15 of NFPA 484, which is AAM chapter, comment on it. That's what we want. We want comments. And the other thing is, I mean, if people are interested in joining, you can join an NFPA technical committee. You just have to apply, and then it's up to the chair of the committee to decide if you get on that committee or not. So, for example, I'm the chair of the wood dust committee, NFPA 664. So I've been the chair of that for almost 10 years. So I've actually been in charge of that committee and the meetings for almost a decade now, believe it or not. So I'm very familiar with the process of selecting people for the committee, and generally it's based on, can you make the meetings, and do you have the proper expertise to be on there. But yeah, so for anyone that is interested, I suggest going to NFPA's website, nfpa.org, and looking up those standards. And you can see any standard for free. You don't have to buy it. Now, if you want to copy text and stuff, you will have to buy it. But you can see they have a tool where you can actually look at any standard you want for free as a reader.
That's awesome. And so that would be useful both for kind of whoever is getting the machine in, operators, but also the fire marshals and things like that as well, who would look at something like that if there's a question about sprinklers or something in that vein regarding AM. Is that like kind of just a really deep dive into kind of a typical facility? Is that a good way to think about
correct.
it?
Yeah,
Okay.
I mean, the one that most people probably look at would be an NFPA 44 2022, which is the most current edition of that. And that's chapter 15, which is actually titled Additive Manufacturing. So that's the one that probably most people, but even FM Global or Factory Mutual have what they call data sheets. And 76, 210, 2.10 actually has a little bit on additive manufacturing as well. So there's more people that are covering it. My hope one day, and I don't know if this will ever happen, I'm trying to pitch it for it to happen, but I'm low on the totem pole, is to maybe one day we'll have an entire standard on NFPA just for AM. So you'll cover dust, but you'll cover other stuff too, because there's other things you need to cover. I don't know how it would work. I mean, you have people like me, you'd have burner manufacturers, you'd have users, you'd have people like yourself, Mike, on there. I think we could be civil. For the most part, these meetings are civil. But yeah, I mean, I think in the future, that's really what we need. We need a committee like that to tackle AM and not just put it into one chapter related to metal.
Mm-hmm. Yeah, and I think ultimately, like, hopefully, like, ultimate priority number one, keep people safe. But then also, like, how do you, if this is going to be a technology of the future and more manufacturers are going to be using it and more applications, like, you want a safe and efficient way to deploy it in a way that makes sense, and everyone can make money. The material manufacturers can make money, and the OEMs and the people selling the goods, right? So I think there's a collective interest in solving this, or at least not solving it, because that's the wrong word, but making it more efficient, maybe. So.
Yeah, for sure. But like I said, I hope one day, I know there's already, what a lot of people don't realize, there's already requirements for powder production in 484. So the powder producers have been bound by that standard for decades now. Not to say that they follow everything in there, but there are requirements. And if any listeners were wondering, can OSHA cite you general duty clause for an NFPA for not violating an NFPA standard? My best answer for that is it kind of depends on the OSHA. I won't get into my real opinion of it, but some of them do, some of them don't. But what you got to realize is standards like NFPA 484 are adopted by the International Fire Code and the International Building Code, and then they're adopted into state law because of that. So while OSHA may not be able to make you do it, the insurance company can. So can the building code official, and so can the fire marshal, because they're in state law at that point. And insurance carriers can basically will just cut coverage, which I've actually seen threatened before, both on the AM and non-AM side. So, but
yeah, that's an interesting dynamic. I hadn't really thought about kind of the insurance side as well on like, and how that comes into play, right?
Yeah, they're definitely involved. I mean, in fact, a lot of people in the U.S. worry about OSHA. I tell people from a combustible dust standpoint, insurance is pushing it much harder than OSHA is, followed by the building and fire code officials. So, though, OSHA is probably third right now. So, but yeah, and there's some insurance companies that are a lot harder on combustible dust than others.
So as we kind of wind down, kind of one final question. I mean, you've shared a lot of kind of good info here. You're going to be at AMUG in a few weeks. You mentioned kind of the NFPA kind of as a resource to learn more about this. But I guess, is there any piece of advice you give someone that is in the position of kind of maybe in charge of safety or starting to think about investing in this technology from a safety perspective? What should they do and know kind of going in, besides your name and number, which will be on on this episode, but what kind of any general best practices or tips at a high level?
Yeah, I think whether you've been doing AM forever, you're just getting into it, so you're going to build or retrofit a new facility, or you're expanding because you're successful at AM. I think the best advice I have is to do the dust hazard analysis. And I'm, like to your point, you want to use me, great. If you don't, that's fine. Just go with somebody else who's qualified. Just check their qualifications. Look at them very closely. Ask them, how many jobs in an AM have you done? Can you give me some references, of some former clients or printer people you've worked with? Because the one thing you do when you do this DHA is you don't want to get someone unqualified, because it's just going to make everything worse in one way or another. But doing DHA is very, very important, even if you've been operating. And, I have people like, well, we haven't had an incident. Okay, that's fine, but that doesn't mean that you're doing everything you need to do. There's a lot of reasons to do it. I always tell people, if the DHA is done right, it's not supposed to be done for compliance, but you're going to get your compliance. So, like, make sure you're in compliance with 484 and OSHA and all that other stuff. But you do it just to gauge if there's any gaps in your performance, so your employees are safe. So that's the main reason to do this DHA. So best advice is to do that dust hazard analysis, to just figure out where you're at and where you're going in the future. Like I said, even if you've been doing it for 10 years, or if you're going to switch powders, or if you're going to get a new printer or whatever else. Because if you do that and continue the cycle, like I have a DHA right now, believe it or not, that's been going on for 6 years. It doesn't stop. And it's primarily because it's a very large R&D facility that keeps buying different printers. So, and every time they buy a printer, I have to extend the DHA. I think we're at 400 pages by now. So it's like a novel at this point. So yeah, the DHA may not ever stop, because you're just going to buy new equipment, or, you're going to formulations. But even again, by doing it and by knowing what all those hazards are and educating yourself through that process, you can catch some of this stuff on the front end, maybe before you buy the equipment or while it's still on paper. And it's a lot cheaper to catch it then and fix it than when you've already installed it and now you got to deal with it. Because now that's going to affect production, it's going to affect safety, it's going to affect costs, it's going to affect everything. So my best advice is, to your point, Mike, is, prior to the process, look up the standards. If you want to read them, great. If you ever need to go to sleep, trust me, read them. They'll do the trick. It's good to at least be educated on what standards are out there, so that way you have a better idea, and educate yourself on what a DHA is, why the qualifications matter, things like that. And then if you're ready to move forward with one, that's going to be probably the step I'd recommend for pretty much everyone in AM, is just do that process to figure out where you're at and where your gaps are. And if you don't have any gaps, at least then you've documented you're doing everything correct. And you should be acknowledged for that, honestly.
Sure. Awesome, Jason. Well, thank you for sharing all this info. We'll share your contact information on this as we kind of post it, and we'll see you at AMUG. So thanks for all the work that you do and helping to keep folks in the industry safe and writing these standards and continuing to push that work forward.
No, thanks for having me on here. It's fun. Appreciate it.